Hello, today I'm going to show you how to factorise quadratics. So first off, what is a quadratic? It's a polynomial with the highest power of 2, and we generally write it in this form, where we have ax squared plus bx plus c, where a, b and c are constants. So x is our variable in this case. We could change it to y, it'd still be a quadratic, but just have a different variable. So what do we mean by factorising then? We want to write this, instead of being like a sum, where you've got loads of addition signs, we want it as a product. So we want it as a multiplication. And it's going to be 2 brackets, 2 because of the square, and we're going to have x plus something, we'll say p, and x plus something else, q, where p and q are constants in this case. Quick note about this method, it's only going to work when a is equal to 1. So kind of we have 1 as the leading coefficient of the power there, of the square. So if it's not 1, there's different methods that work, but this one doesn't work for that. So the first thing to notice is, if we expand these two out, what do we get? Well, we get x times x, which is x squared. We get p times x, so plus px. We get q times x, so qx. And then at the end, p times q. If we now collect the like terms, we have x squared plus p plus qx plus pq. So what we can see, if we think about this original polynomial, the original quadratic we had at the start here, a is 1, so we can kind of ignore that and just think of it like this. What we can see is then, where we have these two terms, the two constants inside our brackets, they multiply together to make c, and they add together to make b. So the way we're going to do it is we're going to look for factors of c, and then hope that they add together to make b, effectively. You can kind of think of two different methods, depending on whether b is positive or negative, and we'll have a look at those now. So let's have this example. We'll have x squared plus 7x plus 6. It's a nice easy one to start with. We look at the factors of 6. We have 1 and 6, 2 and 3. We could write 3 and 2 and 6 and 1, but we've already got each pair appear on here, so it's completely fine. And next we want to see, okay, do they add together to make 7? Well, 6 and 1 add together to make 7, so they're going to be the two ones that we choose. So we have x plus 1 and x plus 6, and that is the factorised form of this quadratic. Looking at another example then, if we have x squared positive, add 2x, minus 8. So now we have a minus over here, and we know that this has to come from one positive and one negative. So what we do is we think about the factors again, so 1 and 8, 2 and 4. Again, we could write the rest of them, but it's all the same thing. But what we know now is that 1 is positive and 1 is negative, so we're looking for the difference to make these two. So here the difference is 7, here the difference is 2, and that matches up with the 2 we have here. So we're going to have x and 2 in one, and x and 4 in the other one, but we still need them to add together to make positive 2. So it's going to have to be the positive 4 minus 2. If it was a minus 2 here, these signs would be the other way around. We'd have positive 2 minus 4, which would make minus 2. Doesn't equal to 0 here, but generally if it was equal to 0 then, to find the roots, you'd have positive 2 and minus 4. Looking at a third example then, here we have x squared minus 9x plus 18. So looking at the factors, 1 and 18, 2 and 9, 3 and 6. Here, this is positive, so we're going to add these together. So this would be 19, this would be 11, this would be 9. So even though this is minus 9, we're still looking for just 9. But what we've got is now the fact that because this is positive, they have to have the same sign. It might have been 2 positives up here, or it could be 2 negatives as well, because when they get multiplied together, they can give a positive number. So in this case, it's going to be minus 3 and minus 6. X minus 3, x minus 6, like that. Beautiful.